Hello children and welcome to your channel Sharda Educare, and in today's video we will be solving exercise 2.1 from your Pythagoras chapter of standard 10. Let's begin children. The first sum we have to identify with reason which of the following are Pythagorean triplet. I hope you can see which of the following are Pythagorean triplet. 3, 5, 4, 4, 9, 12. Let's begin children. For Pythagorean triplet, the three sides or the three numbers which are given, which is the greater number we have to take. Let's take the first one. This is 3, 5, 4. And we want to say whether it is a Pythagorean triplet or not. Out of this 3, which is the greater number? The greatest number is 5. So we will be taking the square of 5. Square of 5 is 25. This is the first one. Now take the sum of other two numbers. Sum of the squares. Sum of squares of other two numbers. So 3 square. Now other two number is this and this. Let us take the sum of square of other two number. What I am getting? 3 square means 9 and 4 square means 16. 9 plus 16 is nothing but 25. If you compare these two, what are you getting? When we compare this, we get that 5 square is equal to 3 square plus 4 square. See, the value of 5 square is 25 and value of sum of the squares of these two numbers is also 25. So, they both are equal. So, by the converse of Pythagoras theorem. Converse of Pythagoras theorem means if sum of the squares of two sides is equal to the square of the third side, then that triangle is a right angle triangle, children. Means if the sum of the squares of two sides is equal to the square of the third side, then this is known as Pythagorean triplet. This triangle is a right angled triangle. So, by converse of Pythagoras theorem, 3, 5, 4 is a Pythagorean triplet. Let's move to the next question. The another numbers which are given is 4, 9, 12. 4, 9 and 12. Out of this three number, which is the greatest number? The 12 is greater number. So, we will take the square of 12. When I take the square of 12, what will I get? Square of 12 is 144. Let us assume it as 1. Now, these two numbers are left. So, square of these two, sum of the squares of these two. So, 4 square plus 9 square. 4 square is 16 and 9 square is 81. 16 and 81, 80, 91 and 97. So, which is, so 4 square plus 9 square is equal to 97, and this is your second statement. If you compare these two, they are not equal. So, we can say statement, we can say that 4 square plus 9 square is not equal to 12 square, and therefore 4, 9, 12 is not, this is the symbol of is not, okay, is not Pythagorean triplet. Let's move to the third question, children. The third question says the numbers are 5, 12 and 13. 5, 12 and 13. Which is the greatest number here? 13 is the greatest number. So let's take the square of 13. Square of 13 is equal to 169, children. And this will be 1. Let's take the square of other two number, this and this. Sum of the square, okay? 5 square plus 12 square. And 5 square is 25 plus 12 is 144. If I will add them, 5 plus 4, so 5 square plus 12 square, I will get 169. And this is my second statement. If you compare this to, this is equal to this. So sum of the square of two side is equal to the square of the third. So I can say 5 square plus 12 square is equal to 13 square, and this is from 1 and 2, and therefore by converse of Pythagoras theorem, the given triplet is a Pythagorean triplet. Okay, children? Let's move to the fourth question, children. The fourth sum is 24, 70 and 74. The greatest number is which one, children? The greatest number is 74. So I will be finding the square of the greatest number. 74 square is equal to what? Seventy-four square is 5476, and this is your first statement. Let's go for the sum of the squares of other two number, this number and this number. So 24 square plus 70 square. 24 square, let's see, children, what is 24 square? It is 576, children. Plus 70 square. Four nine 00. Add them. 576 add with 4900. 0 and 6 will be 6. 07 will be 7, 9, 5, 14 and 5, 4, 7, 6. So what we got, children? This statement and this. See, this is equal to this. So I can say 74 square is equal to 24 square plus 70 square, and this how did I get? I got it from 1 and 2. So by converse of Pythagoras theorem, 24, 70, 74, 24, 70 and 74 is a Pythagorean triplet. Fourth sum is done. Now let's go to the fifth question, children. The numbers are 10, 24, 27. 10, 24 and 27. Out of which the greatest number is 24. Let me take the square of 24. 27. Greatest number is 27. So square of 27. Yes, greatest number is 27. 27 square is 27 multiplied by 27. 7 sevens are 49. 18, 14, 5, 9, 2, 729. So that is 729. It is first statement. What is 10 square? Now take the sum of these two numbers, sum of the squares of these two numbers. 10 square plus 24 square. How much is 10 square? 100. And how much is 24 square? Now only we done 24 square. 24 square is 576. 576. Add that would be 676. That will be 676. So if you compare this statement and this statement, we can say that 27 square is not equal to 10 square, because see, this is 729 children and this is 676. 27 square is not equal to 10 square plus 24 square. And how do we know this? Because from first and second. So we know this from first and second, and therefore 10, 24, 10, 24 and 27 is not a Pythagorean triplet. Is not a Pythagorean triplet. Let's go to the next question. That 11, 60 and 61. The greatest number is 61. So we will take the 61 square. 61 square is equal to 61 multiplied by 61. 1 1s are 1, 1 6 are 6, 6 6 are 36. That would be 1, 12, 3, 7 to 1. 3, 7 to 1. Now find the sum of the square of these two numbers. Sum of the square of 11 and 60. So 11 square plus 60 square, which is 121 plus 3600. 60 square is 3600 children. So we'll get 3600. That would be, if I will add up 3600 with 121, I'll get 127. 3721 children. So what am I getting? I am getting second statement. I am getting 61 square. Value of 61 square is 3721, and value of 11 square plus 60 square is also 3721. Therefore they are both equal. So from first and second, these two are equal. If they are equal, by converse of Pythagoras theorem, by converse of Pythagoras theorem. Converse of Pythagoras theorem. 11, 60, 61 is a Pythagorean triplet. It is very essential to write at the end, children, that because of converse of Pythagoras theorem, 11, 60, 61 is a Pythagorean triplet. Let's move for the next question, children. Pause the video and solve the sum. There is a figure MNP where n is 90 degree. Let me draw the figure. Angle n is 90 degree. And this is M, N, and this is P. So N is 90 degree, okay? This is 90 degree given. Segment NQ means from here we have to draw a segment which is perpendicular. NQ is perpendicular to MP. This is MP, children. MQ is given 9 and QP is given, MQ is given 9 and QP is given 4. You need to find out NQ. Now children, we have already done some of the example. Triangle MNP is a right angle triangle given, okay, it is given here in the question, and from the vertex of 90 degree there is a perpendicular drawn on the hypotenuse, and therefore we need to mention it. We can use, yes, in this previous to this video number 5, we have done the examples based on such questions, and that is geometric mean theorem. Yes, because from the perpendicular, if you draw from the 90 degree, if you draw perpendicular on the hypotenuse, it will be you can use a geometric mean theorem. Let's do it. But geometric mean, before using geometric mean theorem, you must mention triangle MNP is equal to 90 degree. And why it is 90 degree? Because it is given. Then NQ is perpendicular to MP. This is also given. So if it is given like this, then by which theorem? Geometric mean theorem. By geometric mean theorem. And what is geometric mean theorem? Square of the perpendicular side is equal to NQ into QP. Square of the perpendicular side is equal to the product of the divisions made on the hypotenuse. Which are the division? MQ and QP. Okay. Product of the divisions made on the hypotenuse. So we can write NQ square is equal to MQ into QP. Yes, and now NQ we need to find out, and MQ is how much? 9. NQ is a square. 9 into 4. 4 9s are 36. So NQ square is equal to 36. Now in the next step, I will be removing the square root, and I will be placing here, I will be removing the square and placing the square root on the other side. That would be 6 into 6, which will be equal to 6. So NQ is 6 unit, children, because the units are not mentioned here, and therefore it will be 6 unit. We got NQ. Pause the video and solve the sum, children. Let's move for the next question. Question 3. Again we have QPR 90 degree and PM is perpendicular to segment QR and QMR in one line. We have got PM as 10, QM as 8, and we have to find QR. Let's do this, children. Let me draw the triangle first. This is my triangle, which is of 90 degree. Q, P, R is given 90 degree. Clear? Segment PM. PM is perpendicular to, this is PM and this is perpendicular to QR, given here. Perpendicular to QR, it is mentioned here. QMR in one line. So let's write it first. Angle QPR is equal to 90 degree. Okay. PM is perpendicular to QR. See this, QR. And both, this is given, and once it is given, from the vertex, if you draw perpendicular on the hypotenuse, then in that case we can use geometric mean theorem. So by geometric mean theorem, therefore by geometric mean theorem, what will be it? PM square is equal to QM into MR Square of the perpendicular side drawn from the vertex to the hypotenuse will be equal to the product of the divisions made on the hypotenuse. That would be QM into MR. Now let's see what is given. Here PM is given. PM is given 10 and QM is given 8. We need to find out QR. So let's see this. To find QR, you should know MR. And to find MR, you can use geometric mean theorem. Yes, because square of this will be equal to this into this part into this part. So we can use geometric mean theorem here. And what we will get, see, PM square is 10 square, which is equal to QM 8 into QM is 8 and MR as it is. Now 10 square means 100 upon 8, 8 will come down, is equal to MR, children. Now if I divide 100 by 8, 8 ones are 8, 10 minus 8 is 2, bring 20 down, 8 twos are 16, 20 minus 16 is 4. But further you cannot bring any number down, so increase 0, point increase here, 8 5s are 40. So how much you got MR? We got MR as 12.5 and MR is 12.5 here, children. QR is QM plus MR because QMR is given collinear. So QM plus MR is equal to QR, which is collinear given. QM is how much? 8 plus MR is how much? 12.5, which is equal to QR. Now children, I have seen children when they are adding, what they do. When we are adding, see here, 12.5 and 8 will come below 2.0. Add it 5, 12 and 8, 20. So total will be 20.5. So QR is equal to 20.5. This is what they were asking you to find out. Let's move to the fourth question, children. The triangle is SPR. This angle is 30 degree and SR is given 6. It is 90 degree. We need to find out RP. This is RP. I hope you can understand, children. And also we need to find out PS. In this triangle, children, triangle P is given 30, S is given 90. So the third angle can be found easily. In triangle SPR, angle S is equal to 90 degree, angle P is equal to 30 degree, and the reason for this is given. These both are given, and therefore angle R will be equal to 60 degree, and reason for this is third angle of triangle. Third angle of triangle. See, if these two angles are given, you sum them up and it should be equal to 180 if all three angles. 90 and 30, 120, how much you will add to make it 180? 60. So the third angle will be 60 degree. So by looking at this figure, I think we can use easily here 30, 60 and 90 theorem. So according to 30, 60, 90 theorem, if you go to see, the side opposite to angle P is SR. Yes, and side opposite to angle R is SP. So we need to find out SP. We can do it. SR is the side which is opposite to angle P. I can write here SR is side opposite to 60 degree, 30 degree. Opposite to 30 degree, and therefore SR is half of hypotenuse RP. So half into SR is given how much? 6 RP. Now what will happen, children, here? 2 will go with 6 and it will become 12 is equal to RP. So we got RP. RP we got as 12. Yes. Now we need to find out SP. SP is the side opposite to 60 degree. We have already done the angle here. This is 60 degree angle we have got here, see, this angle. So the side which is opposite to 60 degree is SP. Okay, so we can do, first of all we have to write down SP is side opposite to 60 degree. Therefore, by 30, 60, 90 theorem, SP is root 3 upon 2 of RP. SP is to be found, and root 3 upon 2 into RP we have got 12. So we can cancel it. 2 ones are 2 6 are. So SP how much we got? We got SP as 6 root 3 units, children, because centimeter and meter is not mentioned, therefore it will be known as units. Same as here, RP will be 12. You can pause the video, children, and you can solve the sum. Let's move to the next question, children. AB is equal to BC given, children. We need to, this is given root 8. Here is an activity given, children. Let's do this. AB and BC we need to find out with the information given. See here, children, AB is equal to BC, and the reason is given. Yes, AB is equal to BC, reason is given. Angle BAC will be equal to 45 degree, children. You know, children, here I will explain you. In a triangle, if two sides are equal, this side is equal to this side, then this angle will be equal to this angle. Suppose this is a triangle. This is the triangle and these two sides are equal. Then the base angles will be equal, isosceles triangle. Okay. So this will be x and this will also be x. If this is 90, these two angles both are equal. If it is 90, both other two angles will be 90. Sum of the two other angles will be 90. Okay. So x plus x, we can say x plus x is equal to 90, which is 2x is equal to 90. So x is equal to 90 upon 2, 45 degree. So x will be equal to 45 degree. So this angle is 45 degree and this also will be 45 degree. Okay. AB is equal to BC. AB is equal to BC. Why? By 45-45-90 theorem. Yes, AB is equal to BC, not by 45-45-90, AB is equal to BC, AB is equal to BC given, but by 45-45-90 theorem, we can say AB is equal to BC is equal to 1 upon root 2 of hypotenuse. AC is the hypotenuse, na? This is A and this is C. So this AC is hypotenuse. So this value will be 1 upon root 2 of other two equal sides. So AB is equal to BC equal to 1 upon root 2 of AC. AC is hypotenuse. So 1 upon root 2 into root 8. Root 8 it is. Now root 8 can be written as, let me solve it here, 1 upon root 2 into root 8 can be written 2 2s are 4 2s are 8. This is 2 times inside the root, it will come out 1 time outside. So 1 upon root 2 into 2 inside the root will remain root 2. And this root 2 will get cancelled and left will be 2 only. 1 upon root 2 into 2 root 2. You know now why it came to root 2. Now this root 2 and this root 2 will cancel. And what you will get? Only 2. So AB is equal to BC, which will be equal to 2. Both will be 2. You can pause the video, children, and you can solve the sum. Let's move to the next question, children. Find the side and the perimeter of a square whose diagonal is 10. There is a square and the square's sides are given, diagonal is given, diagonal of the square is given, centimeter. Find the side and the perimeter of the square whose diagonal is 10. So this is the square, children, and they have given the diagonal of the square. We need to find out the perimeter and we need to find out the side of the diagonal, side of the square. Let us label it A, B, C and D. So our square is ABCD. Diagonal is given as 10 centimeter. We need to find out the side. In 9th standard you have learned, in lower classes you have learned the property of a square. The first main property of the square is each angle of a square is 90 degree. So we can write each angle of square is 90 degree. So if this is 90 degree, this is also 90, this is also 90, this is also 90. If you go to see, ABD is going to be a right angle triangle because A is 90 degree. Therefore, triangle ABD is a right angled triangle, and therefore by Pythagoras theorem, we know how to use Pythagoras theorem. If this is 90 degree, opposite to 90 degree will be hypotenuse, and we can use BD square, square of hypotenuse is equal to AB square plus AD square. Each angle of a square is 90 degree, and there is one more peculiar property of square. All sides are equal. All sides are equal. If all sides are equal, that means AB is equal to AD. Okay? All sides are equal. AB is equal to AD. So we can say, let AB equal to AD be X. Okay? So we will get here X square plus X square, which is equal to 2x square, and BD is how much given? 10. So we can use here 10 square, which is 100. Yeah, this will be 100. So now 2 will come down. 100 upon 2 is equal to x square. 2 5s are 50. So x square is equal to 50, and now x square is equal to 50, and you know children, square can be removed, and when I remove square, what I need to place? Square root. I need to place square root on the other side. Okay, then it can be it can be written as 25 into 2, and square root of 25 is 5, which can come out as 5, and inside the root will remain 2. So x value is 5 root 2. X means AB, AD, 5 root 2. So this is also 5 root 2. Each side we got equal to 5 root 2. So even AB is equal to AD is equal to what? We can say is equal to what? BC equal to DC, means all sides are equal in a square. So 5 root 2, 5 root 2. What is asked? The perimeter. What is perimeter of a square? The formula for perimeter of square, 4 into side. So we can say perimeter of square ABCD is equal to 4 into side. How much is the side? 4 into side 5 root 2, which is equal to 4 5s are 20 root 2. So the perimeter of the square is 20 root 2 and each side is 5 root 2. You can pause the video, children, and you can solve the sum. The seventh sum, children. DEF is 90 degree. So let's draw the triangle. DFE, F is 90 degree. So F is how much? 90 degree. F is 90 degree. And FG is perpendicular to ED. FG. FG is perpendicular to ED. This is E and this is D. Given. If GD is 8, and FG is 12, okay, find EG. It is very simple, children. Now only we have done the question. Angle F is 90 degree. And FG is perpendicular to ED. Reason for this is given. If these two things are given, we can easily use geometric mean theorem. So, by geometric mean theorem, FG is perpendicular, na? And from here the 90 degrees perpendicular is drawn. So by geometric mean is square of FG square is equal to EG into GD. EG into GD. Let me check this. FG is perpendicular to ED. Okay. And GD is given 8, FG is given 12. Okay, we want to find out EG. Yes. FG square is 12 square, which is equal to EG we want to find out, into GD. GD is given 8. So 144 is equal to EG into 8. Now in the next step 8 will come down. 144 upon 8, 8 will come down, which is equal to EG, children. So 144 divided by 8, 8 ones are 8, 6, 8 eights are 64, 0. So after division we got 18. Okay, so EG is equal to 18. EG was supposed to be found. We got it as 18. Okay. Now what we want to find out? FD. And how much is FD? This is FD. This is what we want to find out. Now look at this figure, children. FG is perpendicular and FG is given 12. GD is given 8. We can find out this because this is going to be hypotenuse. So in this triangle by Pythagoras theorem, so we can use in triangle FGD, angle G is equal to 90 degree. Therefore, by Pythagoras theorem, F G square is equal to FG square plus GD square is equal to FD square. How much is FG? 12 square plus GD square 8 square, which is equal to FD square. 12 square is 144 plus 64, which is equal to FD square. 144 and 64, 160, 208. 208 is equal to FD square. So take the square root. Under the root 208 is equal to FD. So take the square root of 208. 208. 2 ones are, zeros are, 4s are. 2 5s are, 2s are. 2 1s are, 2 2s are. 2 2s are, 4 2 6 are. 13 2s are, 2 1s are. Now under the root what will come? Let me write that here. See children, under the root what will come? 1 2 3 4 times 2. 1 2 3 and 4 times 2 and 1 time 13, which is equal to FD. 1 time 2 time. So 2 into 2 is equal to under the root, this will come out because it is 2 time. This is 2 time, so it will come out as 1 time. This is also 2 times, so it will come out as 1 time. So what is left now inside? 13, which is equal to FD. So FD is 4 root 13. So we can easily write here FD as 4 root 13, and this is what they were asking you to find out FD. It is also, they are also asking you to find out EF. To get EF you will be using Pythagoras theorem in this. Now this is the homework children. Let me see how you solve it. I will just discuss with you. This FG is perpendicular to ED. So this is going to be 90 degree. So you will be using Pythagoras theorem in this. FG square plus GE square, which is equal to EF square, 12 square plus 18 square, and then square root take and get the value of EF. Let us move for the next question children. So dB is equal to under root 37 into 37, which is equal to dB. Therefore dB is equal to 37. We needed to find out the diagonal. So we got diagonal as 37. You can pause and you can solve the sum. Let's move to the next question, children. There is a triangle. M is midpoint. This is R. This is P. This is Q. And we need to find out, we need to prove that PQ square is equal to 4 times PM square minus 3 times PR square. We will see the question and we will do the sums, children. The question says PQ square. So PQ square, how will I get? This is PQ. PQ square, PQ is opposite to 90 degrees, so it is hypotenuse. So we will use Pythagoras theorem in triangle PRQ. Okay. So in triangle PRQ, angle R is equal to 90 degree and this is given, therefore by Pythagoras theorem, we will get PR square plus RQ square is equal to PQ square. I wanted PQ, I got PQ. Now further what I want PM square. See, this is PM square. So PM I am getting where? I am getting in triangle PRM. Okay. So let me take in triangle PRM. In triangle PRM, again R is equal to 90 degree and this is given. So by Pythagoras theorem, therefore by Pythagoras theorem, you need to write again and again, children, because you cannot use Pythagoras theorem if you do not mention that it is a 90 degree angle. Okay, so you need to write by Pythagoras theorem, otherwise your marks will go. PR square plus RM square, PR square plus RM square is equal to PM square. PR square plus RM square is equal to PM square. But see, children, RM is equal to half of RQ. So I can write PR square plus half of RQ, the whole square, is equal to PM square. And why it is like that? Because RM is half of RM is equal to MQ. And why RM is equal to MQ? Because M is the midpoint given. Clear? So now what we get from here? We get PR square is equal to 1 upon 4, sorry, not equal to, plus 1 upon 4 RQ square is equal to PM square. Now I want 4 times PM square. Now multiply throughout by 4. Clear? What will I get? 4 PR square plus 4 RQ square upon 4 is equal to 4 PM square. And what will happen now? 4 and 4 get cancelled and you will get 4 PR square plus RQ square is equal to 4 PM square. Now I want PQ square is equal to 4 PM square. Now I will bifurcate this. Three PR square plus PR square plus RQ square is equal to 4 times PM square. See, 4 times PR was there, I wrote 3 PR and 1 PR, that is equal to 4 PR. And here if you go to see PR plus RQ, PR square plus RQ square is what? PQ square. So in place of this I can write PQ square. So I will be able to get 3 PR square plus PR plus RQ. See here, PR square plus RQ square is PQ square. This value I will be placing over there. So I will be getting PQ square, which is equal to 4 times PM square. I wanted 4 times PM, I got 4 times PM. And after 4 times PM I wanted minus 3 PR. So I will be shifting PR to this side, and I will get PQ square is equal to 4 PM square minus 3 PR square. This is what I wanted, and we got it. Hence proved. Done, children? Wall of the two buildings on either side of the street are parallel to each other. Means there is a street in the middle and there is one building. There is one building here and this is another building here, and in the middle this is the street. This is the street, okay, and these walls are parallel to one another. A ladder 5.8 centimeter long is placed on the street such that its top just reaches the window of the building at the height of 4 meter. So there is one building which is at the height of 4 meter. Suppose this is the building which is of 4 meter height, and I keep a ladder. Let me draw the diagram properly. So this is one building whose height is 4 meter, and this is another building. The ladder is placed here in the middle, and the ladder reaches at the window of the building at the height of 4 meter. The ladder is 5.8 meter. Children, ladder is 5.8 meter, and this 5.8 meter ladder will reach the top of the window, top of the building's window, which is 4 meter. So find the width of the street. We want to find out the width of the street, okay, this width. Fine. So if you go to see, children, when ladder is placed, you get a triangle here. It is 90 degree. Label it as A, B, C. Clear? And by Pythagoras theorem you can find out. So in triangle A, B, C, angle B is 90 degree. So by Pythagoras theorem, we will use Pythagoras theorem afterward. First we will see for next half of the sum. On turning the ladder, if you turn the ladder this side, the ladder over to the other side of the street, on turning the ladder over to the other side of the street, its top touches the window of the other building at a height of 4.2 meter. So the top will touch the other two building which is at a height of 4.2 meter. Means this other building is at a height of 4.2 meter and the ladder will remain 5.8 only, na? When you place the ladder here, it is 5.8. When you turn and keep it here, it will be 5.8 only. Okay. It touches the top of the building which is 4.2 meter. So again in this we can use, label it as PQ, C. In this also we can use Pythagoras theorem. This is a hypotenuse, it will give you this value, and in this sum you will get this value, add both and you can find the width of the street. Let's do, children. In triangle ABC, by Pythagoras theorem, AB square plus BC square is equal to AC square. Now AB is how much? 4 square. We want to find out BC square, which is equal to AC. AC is 5.8 square. Now 16 plus BC square, which is equal to 5.8 multiply 5.8 2 times 5.8 square. Okay, 8 8s are 64, carry 6, 8 5s are 40, 46, 5 8s are 40, 5 5s are 25 plus 4 29. So 4, 6, 13, 1 3, 3 3 6 4. Now point will be after 2 digit. See here, 1 2. So I will be placing the point here, 3 3 6 4. You will get 33.64. Now do the subtraction. BC square is equal to, this number will come here, 33.64 minus 16 minus 16, subtraction do. Now how to do the subtraction, children? 3.64 minus 16, 16 I will write here, then 0.00, subtract it, 4, 6, 13 minus 6 would be 7, 2 minus 1 will be 7, 1. So BC square is equal to 17.64. We need to find out the square root, okay, of BC, that is 17.64, and I have told you how to find out square root in the before sum. Make the pairs, take a number, 2 2s are 4, 3 3s are 9, 4 4s are 16. We can take 4. Yes, 4 4s are 16. Yes, 4 4s are 16. Then minus 1, 7 minus 6 is 1, 64 will come down. Add 4 here, 4 plus 4 is 8. Now I need to write here any number so that I should multiply. If I write 1 here, so 81 multiply by 1 will be 81, which is very small. So what I will do, I will write 82, 82, 82 multiply by 2, 2 2s are 4, 2 8s are 16. So 164, 1.64. So here will be 0.2, 1.64, 0 0 0. So 4.2. So BC is equal to 4.2 centimeter. Meter, not centimeter, it will be meter. 4.2 meter. We got 4.2 for this is 4.2 value. Now we want to find out CQ. For finding the value CQ, you will have to take triangle. In triangle PQC, Q is equal to 90 degree, angle Q. Therefore, by Pythagoras theorem, okay, what we will get? PQ square plus CQ square is equal to PC square. PQ is 4.2 square plus CQ square is equal to PC square. BC is 5.8 and 5.8 square we have already done here. 3.64, 3.64 and 4.2 we got here 1764. See, 4.2 we multiply 1764. So here we will write 17.64 plus CQ square. See children, already we have got now 4.2. Square root of 4.2, 1764 is 4.2. The square of 4.2 is 1764. Clear? So now CQ square is equal to 3.64 minus 17.64. Subtract it. When we subtract, if I am subtracting, let me subtract it here. 3.64 minus 17.64. Subtraction will give me 0.6. From here I will take 1, 13 minus 7 will be 6, 2 minus 1 will be 1. So 16, I am getting CQ square is equal to 16. So when I take the square root, CQ is equal to under root 16 and square root of 16 is 4. So we will get this as 4. Now when we add, to find out the width of the street is what? BC plus CQ. So let me write it here at the top. CQ plus CB is equal to BC. And how much is CQ? 4 plus 4.2, which is 8.2 meter. So width of the street is 8.2 meter. You can pause and you can solve the sum, children. This complete 2.1 exercise. So like my video, children, share my video, subscribe my channel if you have not subscribed. Thank you for watching, children.